diameter, but we are constantly pushing the limits, and we are reaching the 20-meter diameter mark soon. So since we are dealing with mechanized equipment in the underground, the mining business is, of course, something we are also pursuing. The mining business is lacking skilled personnel, and that's why they are approaching us, and if we cannot provide proper equipment to minimize the amount of labor underground and to increase the safety and the economies there. We are also doing exploration, so not just for oil and gas, but also for geothermal. You might have heard in Germany we shut down our nuclear power plants. So no nuclear power anymore. We want to reduce our gas and coal consumption for energy production. So we want to go 100% renewable soon. And so we are relying on wind, solar, and geothermal. So geothermal is the energy source we are really heavily relying on. And what I'm hearing, you also have fantastic opportunities in your country to also utilizing this kind of energy source. Well, my topic is sewer and water installations, trenchless, so you don't need to tear up the roads anymore, so you can go trenchless underground, and I want to show you just a few installation methods. This one is the most popular one, is a HDD, it's horizontal directional drilling. You basically use a HDD rig and drill a pilot bore, and depending on the diameter of pipe you want to install, you are reaming, you are upsizing your borehole underground until it is big enough to accommodate your product pipe. So as final step, you pull in your product pipe, and then your pipeline is installed and you can go in operation. Well, there are several rigs available in the market, so we are specialized in the maxi or in the bigger rigs. So HDD rigs already in the market. The next step would be the microtunneling and pipe checking. The pipe checking basically uses two shafts. You have a launch shaft and a reception shaft, and you're advancing the machine underground and pushing pipe by pipe the machine forward into the ground. So this is a remote controlled installation method where nobody is in the tunnel, nobody is in the shaft. It's just one operator sitting on the surface in a 20-foot container. So that's basically the process. You have a shaft, you have a thrust cylinder, thrust block, which is supporting the shaft properly, and then you're advancing the machine. The red piece is a cutting wheel. The cutting wheel is cutting the soil, and then you have the first two machine sections to articulate, and that's how you steer. And then once you're advanced for a section of 3 meters, so the typical length of the checking pipes are 3 meters, so you stop, you disconnect the feed and discharge lines, and you install the next checking pipe sections. So you have basically bell and spigot connections with a sleeve around in order to allow curved alignments to articulate between the pipes. So basically the pipes follow the machine into the excavated space, and that way you can go arbitrary curves, arbitrary distances. It's more or less up to you. The trend goes to longer distances, so basically up larger than 1 kilometer in diameter. So longest pipe checking operation we have been involved for is 2.5 kilometer in diameter. And if you go longer distances, you always have to keep your checking loads in balance, so you need to monitor it properly, and that's why this bentonite lubrication around the pipe is quite important, to monitor it and to control it while you're advancing. Obviously, we are in the ground, we need to cut the soil, and what is the toughest soil we can handle or we see during the operation is hard rock, obviously. So if you have volcanic rock, it's quite tough to cut through, and that's why the ground is an important part. We tailor the machine and the cutting wheel and the cutting tools to the ground conditions in order to make the project a success. So this animation is showing you're basically spinning the cutting wheel and the tools, you're breaking the rock and boulders and cobbles in front of the machine with the spinning of the cutting wheel. And then the machine itself is acting like a coffee grinder, so you have a crusher chamber, and on the crusher chamber you grind down the particles to smaller sizes, so that's small enough to fit through the openings on the invert of the crusher chamber. And the green line, when you look at the green line, that's how the materials, the soil, the rock, the small particles are pumped back outside the tunnel to a separation plant on the surface where it's cleaned, and the clean bentonite is recirculated into the excavation chamber. Basically, that's a simple system. You're just pumping a bentonite slurry in a loop, and you're adding the soil in the excavation chamber underground, and then you're removing it on the surface again via shakers and screens, etc. So depending on ground condition, and especially the hardness of the rock you are encountering during the drive, you pick the most appropriate size of machine. Obviously, the harder the rock, the bigger the machine needs to get in order to accommodate enough tooling to break the rock. So the dominating factor is the unified compressive strength given through the geotech report. One of the best-selling products and the most popular one is AVN 800HR. HR stands for hard rock. So this machine can handle hard rock up to 200 megapascal, but also can handle anything in between. So whenever you are using such kind of machine, you don't need to worry about what kind of ground conditions you are in. It can handle everything what you might encounter. So that's a very versatile one with 800 millimeter in diameter, and that's maybe one we might see in the future also hopefully in Dar es Salaam projects and in Tanzanian projects. Because you don't need to worry about if you're above the groundwater level or below the groundwater level. That works in any case here, and the footprint is quite small. It fits in a very small shaft of 3.2 meters in diameter. That's how you launch it, the machine out of a simple shaft and then advance it forward. Now, since these machines are also operational under the groundwater level, they obviously can also go can be used for sea outfalls or lake outfalls, river outfalls. Quite popular are these sea outfalls, for instance, for desalination plants on the coastal areas. Desalination plants need a water inlet, seawater inlet, to produce the water, and they have the brine outlet. Another application, for instance, is for power plants, like here a project in Ghana, where on the shoreline a big power plant has been built, and the power plant needed cooling water, and so this technology has been used to install the lines for the cooling water. So you're basically circulating seawater here, you pump it from the ocean to the power plant, and then you cool the power plant, and the warmer water afterwards is released back into the ocean. And therefore, basically, 2 lines or 4 lines have been installed out of a shaft. The longest one was 1.1 kilometers, so you have them on different exit points. And so that's basically showing the lines connecting the power plant with the ocean here. That's on the left side the acceptance of the machine and the party, or the kind of blessing of the machine, etc., and the whole operation. Before starting of the project, the right one is a picture of our facility when the machine is getting ready. Here you have a couple of photos. On the left side you see a reception shaft. You basically see the launch shaft on the bottom side, and then it's pushed out into the ocean, and in the ocean you see a checkup barge, and that's where the machine is being recovered once it reaches there and brought back onshore and made ready for the next operation. Basically in the middle you see the shaft, so again you need a shaft to launch the machine and push it to a launch seal and do all the excavation. Well, another technology is this one. It's called direct pipe. It's also using a microtunneling machine, but instead of building a shaft, you can launch it from the surface. So it's a surface-to-surface operation, and the technology which made it possible was a pipe thruster. You're basically having a large clamping unit which can clamp a steel pipe. In this case, it's a steel pipe. For microtunneling pipe string, typically we use reinforced concrete pipes. Here it's a steel pipe, can be clamped, is strong enough, and is also not absorbing water, so it's a slick outer surface, and therefore your friction loads can be minimized. You only what you have to take care is the launch seal itself. Everything needs to go through an entrance seal, otherwise you would flood the shaft. So and once you enter into the groundwater, etc., you need to push everything through a seal. And the biggest benefit of this technology versus a horizontal erection drilling, HDD is only possible in certain ground conditions. So you have a certain degree of fine content, so you need minimum 30% of fines in your ground, in your geotech report. If that's not the case, the HDD method is not applicable, or if you use it, you're losing circulation, you're basically fracking out, and your bentonite will show up somewhere else, not in the area where you want to have it. So that's a kind of a worst case scenario, fracking out into the environment, and that's what needs to be avoided, and that's why this slurry microtunneling and direct pipe method is quite convenient. And you also don't need a reception shaft. In this case, you know exactly where the machine is located, is arriving, you dig around with your excavator and remove the machine. Now, the latest development made it possible to build this machine down to 26 inches, which is quite small. It's about 500 millimeter in diameter, and that's the smallest one we could use here. And I'm not sure if I stayed within the 15 minutes. I think I made it within 10 minutes. So I'd like to invite you. Here are my contact information, so in case you have questions. We are working together with the Chamber of Commerce, the German Chamber of Commerce here in Tanzania, and Dar es Salaam. They have an office here, and we would love to interact, get involved in it's a project at an early stage, and we love to support you, help you to develop challenging projects and get these kind of technology started in your very nice country. Thank you, asante sana, and sorry for not speaking and understanding Swahili, but maybe my next life. All right, thank you.
Thank you, Dr. Lang. Tafadhali makofi tena kwa daktari. Asante sana. Sasa naomba niwakaribishe presenters wanaofuata kutoka Vodacom. Nuru Kesi na Ivan Bayona. Sina hakika kama watafanya hii kwa pamoja, lakini hii ni fursa kwao. Kama wapo tafadhali.